In this video, what we want to do is prove that asymmetric implies antisymmetric. I'll try to talk about the relations here a little more in the future, but asymmetric is actually pretty intuitive. It just says that if x has a relation with y, then that implies that y does not have that relation with x. So a good example of that is like your father. For example, my dad's name is Bill. My name is Alan, so we can say that Bill fathered Alan. So this is our x, this is our relationship, and this is our y. However, obviously if Bill fathered Alan, then that means that it is not the case that Alan fathered Bill. And that's what it means to be asymmetric. It only goes one way, but it is not the case that this relation applies from Alan to Bill. And that is true of all people. There's nobody who is the father of their father. So therefore we say that that relationship is asymmetric. As opposed to being symmetric, for example, I'm married, my wife's name is Brooke. We could say that Alan married Brooke. And again, we have our x, we have our relationship, and then we have our y. But whenever somebody gets married, it is always the case that if x marries y, then that y married x. So it goes back and forth, which is why it is symmetric. Whereas here, if it's the case that x fathers y, then y never fathers x. It is not possible. So an example of an asymmetric relationship would be greater than. If we say that 7 is greater than 3, this is our x, our r, and our y. It is never going to be the case that 3 is greater than 7. So therefore, this relation is considered to be asymmetric. An example of a symmetric relationship would be the equality. If you have 3 is equal to 3, then this is going to be our x, our r, and our y. And it's always going to be the case that if this relation holds, that we are going to have a reciprocating relation between y, r, x. Now this example is a little weird because, x and y are the same number, but if we had 7 is equal to 3, well clearly this wouldn't be true, so therefore the relation wouldn't hold. So we wouldn't even say that that relation holds for x, r, y. Antisymmetric is a little harder to make coherent, but if we have a relationship like, for example, 4 is going to be greater than or equal to this yellow 4. And I'm only making them different colors so I can point out that the light blue one here is going to be our x, this is going to be our relation, and then this is going to be our y. Then we have the and symbol, which again, it is the same number, but you just have to imagine that we're swapping the sides here. But this is going to be our y, and then the other 4 with the x. So this is the basic premise of antisymmetric, saying that if we have the case where x, r, y, and we do here because 4 is greater than or equal to 4, and we have the case that y, r, x, which again we do because 4 is greater than equal to 4, then that means that we have x is equal to y. And indeed, we do have the case that 4 is equal to 4. So this is in fact an antisymmetric relation because this essentially is our P, this is going to be our Q, and we have P implies Q. This side is all true because we have that 4 is greater than or equal to 4, and we have that 4 is greater than or equal to 4, and then that implies that 4 is equal to 4. And as long as that holds true, then that means that the relation is going to be antisymmetric. So the relation greater than or equal to and the relation less than or equal to are both antisymmetric. But the actual question that we have wants to prove that asymmetric implies antisymmetric. So all I've done is rewrite both of these definitions down here. This is basically saying that asymmetric implies antisymmetric. Now, I'm sure there's many ways to prove this. I'm going to use a truth table, though, because I think if you look at the components that we have, it makes sense to do a truth table. We have xry here, and we have xry here. We have yrx here, we have yrx here. We don't really know the truth value of x is equal to y, but when we put it all together, you'll see that it doesn't really matter. So I'm going to try to do a truth table down here. I don't know how much room I'm going to have, but we'll see. Right off the bat, we know we want to have xry and yrx. So I'll do xry, yrx. And we want to have every possible combination. So we're going to have 0, 0, 0, 1, 1, 0, and 1, 1. That's every possible combination we can have. Basically meaning that both xry and yrx are going to be false in this first row right here. In the second row, we have that xry is false and then yrx is true. Here we have that XRY is going to be true and YRX is false, and then we have that they're both true on the bottom row. Now what we have up here is a not YRX, so I'm going to go ahead and not that. I'm going to not YRX. So all I need to do is reverse all of these here. We have 1, 0, 1, 0. Then we want to look at where XRY implies not YRX. Here's where I'm going to start running out of room. XRY implies not YRX. So we're ignoring this column here. We're only looking at XRY here. So XRY is going to be 0 and 0. So it doesn't matter what YRX is. We're going to say that this is vacuously true because our premise is false. So that's going to be a 1 and a 1. Then we have that XRY implies not YRX. That's going to be a 1 and a 1. That is also true. And then here we have XRY is a 1, not YRX is a 0. That is where this is false. Then I want to look at what we have here for antisymmetric is XRY and YRX. So now I want to look at antisymmetric. We can see our premise here is XRY and YRX. So I'm going to write XRY and YRX. Now in order for this column to be true, we need to have the case that XRY and YRX are both true. Note that this is an and sign, it's not an implication, so it's not like if XRY is false, we can say that YRX is vacuously true. This entire thing goes together. It's not an implication, we need to have both XRY and YRX. So here we have 0 and 0, so this is going to be a 0 because we have neither of them. 0 and 1, this is going to be a 0 because we need both of them. 1 and 0, this is going to be a 0 because we need both of them. And then finally we have 1 because this is the only row where we have both XRY and YRX. Now if we look at what we're actually trying to prove, we're trying to prove that this implies this. So XRY implies not YRX is our basic premise. And then the next thing I want to look at is the right side of this implication, which is X is equal to Y. But what we really want to know is this entire relation, XRY and X and YRX implies X is equal to Y. At this point, we really don't know what the truth value of X equals Y is. We don't have anything to really go off of based on the information we have. But what we can say here, we have XRY and YRX. This is 0, so this is going to be a 1 because it's vacuously true. We don't really care what this value is. So I write DC for don't care. Here, once again, we have XRY and YRX is false. So again, this entire right-hand side is going to be true because we don't really care what X equals Y is. And then same thing here. We don't care because if this is false, this is always going to be true, whether this is true or whether this is false. And then the only time where we have that this premise is true is when this premise is false. So again, we don't really care because what we want to know is what this entire implication is. So for the case where XRY and YRX implies X equals Y, we don't really know what this value is, but again, we don't care. So now I only want to look at two columns. I want to look at this column right here and this column right here, because these are the two columns that make up our implication. XRY implies not YRX, implies XRY and YRX implies X equals Y. And if I had more room, I would make another column for this, but I'm running out, and I think if I put it up here, it might be a little sloppy. Bear with me here. All I did was rewrite this equation right here. I'm just writing it up here. So you can imagine this being another column that we added on to the right side here. But again, we just want to evaluate the truth of this. XRY implies not YRX. Well, we can see right here that XRY implies not YRX is true. So this part is true. And we want to see if that implies this part right here, which we can see right here is 1. So that means that is true. That's going to be true for the first row. Then we can look at the second row. XRY implies not YRX. This is going to be true. And this is going to be true. So again, we can say that this is true. Here we can say the same thing. This is true and this is true. So we can say that is true. And then finally, we can say that this is a 0. And because it is a 0, we don't care what this is. It's also going to be true. So we can see that for all scenarios where XRY implies not YRX, Or in other words, in all scenarios where it is asymmetric, it does in fact imply that it is antisymmetric, because this is our equation for asymmetric, this is our equation for antisymmetric.